In lesson 2, we're going to determine the equation of a line in slope y-intercept form. Now we've done this before also in our previous unit, so a lot of this should be reviewed, but maybe there's some new little concepts. So if you recall, we use y equals mx plus b for the equation of any straight line, with the exception of our horizontal and vertical lines, which we'll talk about at the end. So all lines except for horizontal and vertical lines, all straight lines, can be described using this equation, y equals mx plus b. And again, we call this the slope y-intercept form of a line. Why do we call it that? Because the m right here represents the slope, and the b represents the y-intercept. Now in our previous unit, we used to always call the y-intercept the initial value. And it's got different names, just like the slope can be rise over run or rate of change. The y-intercept also has different names like initial value. So let's talk about how we find the equation from a graph. All right, so the y and the x represent our dependent variable and our independent variable. They represent possible coordinates on the graph. So let's go over to this graph and talk about how we're going to find these things. Now the first thing I notice about this graph is it's missing its arrows. So any line that continues on forever, should have arrows on it. Okay, so we'll add those on. Now, the easiest thing to find is the y-intercept, and that's what we're going to start with right here, the y-intercept. It's also called the initial value, like we said before. Where is that? It's the place on the line, the coordinates on the line, where your line crosses the y-axis. So this is our y-axis right here. This is our x-axis. So where does our line cross the y-axis? Right there. So what are those coordinates? 0, 3 in this case. So looking back down here, the coordinates of the y-intercept will always have, the x-coordinate will always be 0. So x is always 0 here, because if it's on the y-axis, the x-coordinate's always 0. So in this case, b in our equation is going to be 3. Now again, the x is 0, b is 3, okay, for the y-intercept. So that's that coordinate. Now the next thing we want to do is let's find the slope. So the slope is m. Now in a graph, we use rise over run. Now remember, if a line is going up from left to right, it looks like this, it has a positive slope. If a line is going down from left to right, like this, it has a negative slope. So our line is going to have a negative slope because it's going down from left to right. So to find the slope, we need to find another point. So I'm going to look along the line here, and I see another point right here. So let's do the rise and run. I'm going down 2 and over 3. So the rise right here, we're going down 2, and the run right here, we're going over to the right 3. So the rise is -2 and the run is 3, and that's our slope. Okay, those are the only two things we need to find the equation of a line, and now we can write it out. So in y equals mx plus b form, we are going to leave the y as y. We're going to place the m with our slope. Now again, our slope is a fraction here, and we're going to get a lot of fractions, so we're going to leave everything as a fraction in this unit. If it can be reduced, reduce it, but leave it as a fraction. So -2 over 3 would be, if we wrote that as a decimal, right? If we go 2 divided by 3, we get -0.66666666. So instead of writing that, we're just going to write as a fraction. All right, and then we put plus or minus whatever b is. In this case, it's 3. So there's my equation. Y equals -2 over 3x plus 3. That's the equation of that line. So we've done this before. If you're looking at this thing and this is pretty similar, you're right. Okay, except now we're not replacing the y and x with other letters. It's always going to be m, y, and x, and it's the same thing every time. So let's go down the page, and we're going to do a few more quick examples. I'm going to do them a little quicker here, same idea. All right, so here's 3 more examples, and right off the bat, these lines are also missing their arrows. If a line doesn't have an arrow on each end, it's actually called a line segment, which means it ends. So for these to be proper lines and continue forever, they're supposed to have arrows. Okay, so let's find the initial value for each of these. This one has an initial value, look at 0, 2. So that means its b is 2. This one's initial value, or we also call it the y-intercept, 0, 6. So its y-intercept is 6. And this one crosses through 0, -3. So its b is -3. So that's pretty easy, right? Just looking on the y-axis, where does the line cross it at? And what is the y-coordinate? And that's what we're going to make b in our equation. So 2, 6, and -3. The slopes, each time we're going to use rise over run. Now, we need 2 points. The easiest point is use that y-intercept point that you started with and just find one more point on the graph. So look, here's a point right here. Or I could use this one, or I could use this one, or I could use this one. But notice no matter what, I'm always going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So that means my rise is 1 and my run is 2 in each of these cases. So there's my slope. So let's do the next one. Same thing, rise over run. Now, this line is going down from left to right, and this is what students tend to forget a lot. This is a negative slope. It's going down. So let's find some more points. There's a point there. There's a point there. Now, like I said, in the last one, I looked at a bunch of points, but I really, whenever I do this, I just start right here at my y-intercept, and then I do my rise down 1, 2, 3. So it's -3 for the rise, and what's my run? 1. And then you can check it by doing another one, 1, 2, 3 over 1. So both of them are -3 over 1. Now -3 over 1 we can definitely reduce and write as -3. We don't want to leave that as -3 over 1. It's not fully simplified. The last example here, I'm going to start at that point again, and let's find another point on our line that we're pretty sure of. You know what? I think if we take a good look, I think all of these are points, right? Look at every one of these as a point. So let's see. The rise is 1. The run is 1. The rise is 1. The run is 1. And this is positive because it's going up from left to right. So rise of 1, rise over run. And make sure when you do the work, write out your steps, write out your formulas, okay? If all you're doing is writing final answers, you're not going to get full credit. I want you to show me a full, because I'm not giving you a lot of work. So full, neat, complete solutions. So back to this one. 1 divided by 1 can be simplified to 1. All right, so let's write out the equation for each of these. Y equals mx plus b. All we have to do is we leave the y, we leave the x. Our job is just to substitute in the m and the b. So the m in this case is 1/2 and the b is 2. So 1/2 x plus 2. In this case, y equals mx plus b. We're going to sub in m, sub in b. Y equals -3x plus 6. And our final answer, y equals mx plus b. All right, so the m is 1. And the b is -3. Now, this last one, look how kind of silly that looks. 1x plus -3. We want to clean that up. 1x is just x. So we're going to we know that there's an invisible 1 in front of that. And then plus -3, we just write -3. So that's our final answer for each of these. So this is what basically, when you do your work, I want you to show all your steps, and then I want you to basically write your final answer and basically put a box or something around it. Make it really obvious there's your final answer. And look at all that work above. I've shown clearly I know how to calculate all this, not just write down a final answer, but I know how to calculate, show my work on the graph. So whatever I'm doing here is expected of you. Okay, the last thing we want to talk about is the horizontal and vertical lines. Those are the two ones that always cause everyone lots of trouble. Obviously, you know, it was pretty easy to find rise and run. We've done that a lot. It's easy to find the y-intercept because we've found initial value before. These are the two weirdos. So let's say you have a couple points here. Let's look at this in a bunch of different scenarios, right? All right, so we got the coordinates 3, 5, and -4, 5. So let's graph those. 3 over 5 up is right here. There we go. There's 3, 5. And -4 over 5 up is right here. Now, obviously, right off the bat, that's going to make a horizontal line. Let me just get my ruler out here, and I'm going to draw a line through those the best I can. There we go. Okay, you can watch me try to adjust that. Boom. All right, so there we go. That is a vertical line. Or sorry, horizontal line. And obviously, we talked about this in our last lesson. Look at anytime we have a horizontal line, we are going to have the same y-coordinates. So points on horizontal lines always have the same y-coordinates. So right off the bat, if you ever catch that, you know that that's a horizontal line. Now we also talked about something else yesterday in our previous lesson. The slope of a horizontal line is always the same no matter what. So let's use our slope formula we talked about. y2 minus y1. So I'm going to label these here as, let's label this, get rid of that, x1, y1, x2, y2. And let me do my slope formula, remind you about that. y2 minus y1 over x2 minus x1. All right, so we have 5 minus 5, which is 0, divided by -7, and 0 divided by -7 is 0. So if you remember from the previous lesson, all horizontal lines will always have a slope of 0. So there's a lot of little facts here we want to keep straight, and we really need to focus on memorizing and learning, okay? Now, how do we write the equation of any horizontal line? It looks like this. Let's start with y equals mx plus b again. Now, if we sub in what we know from before, we know the slope is 0, so 0 times x. And what's b? Well, b is where it crosses the y-intercept at. So where does it cross at? 0 over 5 up. So 5 is what b is. So y equals 0x plus 5, but 0 times x is 0, so all that's left is y equals 5. That's the equation of a horizontal line that passes through 5. So all equations, all horizontal lines have an equation of y equals a number, and that number is always, if you read down here, where the number is the y-coordinate of every point on the line. Look at the points up here, 5, 5, 5. All the y-coordinates are always 5. So every horizontal line we just write y equals whatever the y-coordinate of the point. We can skip all this work. You don't have to show all this work. What I'm trying to do is just show you how it's all related, how it has a slope of 0, how all the coordinates on this line have a y-coordinate of 5. So the shortcut is you don't have to do all this work. If you see a horizontal line, you just write y equals the y-coordinate. Now there's a very similar thing with vertical lines. Let's graph these points. Negative 3, 4, so negative 3 over 4 up right here, and negative 3, negative 5. Okay, so these are these points right here. x1, y1, I'll label those because I'm going to do the slope formula 2 in a minute. And obviously, you can see right off the bat, that's going to make a vertical line. So if I draw a line through it, there it is, right? There's that vertical line. Oops. Right, let me even label these points. What do we have here? Negative 3, 4, and negative 3, 5. Okay, now, if you remember from the previous lesson, we found the slope, so let's do our slope formula here. Just to review how to do that. y2 minus y1, so negative 5 minus 4, and x2 minus x1. So I got a double negative, got to be careful. So that gives me negative 9 over negative 3 plus 3, because it's a double negative. Negative 3 plus 3 is 0. Now that's not 0. Remember, that is an undefined number. Okay, so I'm just going to use the number sign here for short. All vertical lines have a slope that is undefined. Every single one of them. Now that's not the equation. That's the slope. So like I said, there's a lot of little details to keep straight here, and maybe you want to watch this video a couple times and write down these notes, okay? So how do we write this equation? This one's a wacky one. We can't use y equals mx plus b, but look at the one over here, right? Look at the horizontal line. It's just y equals whatever the y-coordinate is. It's the same thing with the vertical line, except instead of y, it's x equals whatever the x-coordinate is. Look at the x-coordinate, negative 3, negative 3. Look where it crosses the x-axis at. It crosses is at negative 3. So all we write is x equals negative 3. Now again, these two lines don't follow the usual rules of all the other lines, okay? These are the two weirdos. So as soon as you see a horizontal line or a vertical line, you don't have to do much work. I wrote a lot of work out here to just try to get an idea of what's going on. But it's actually really quick. All you have to do for a horizontal line is just write y equals the y-coordinate, and for a vertical line, write x equals the x-coordinate. So let's do a quick look at just a few quick examples, and I can show you just how fast you can do them if you memorize these facts. Okay, so let's look at just a couple quick examples. These are really fast, easy lines to find the equation of if you know the little tricks we were just talking about. These are obviously horizontal and vertical lines. So first things first, looking at these first two lines, the blue line here and the green line here. If someone said, all right, what are the slopes of those lines? Well, they're both horizontal, so both of these have a slope of 0. M equals 0 for both of these, right? Slope is 0. So remember, slope is steepness. So these are horizontal. Horizontal is flat ground, right? It has no steepness. Now, this is how quick and how easy it is to find the equation of a horizontal line. Look at this line. All it is y equals whatever the y coordinate is of any of the points. Every one of these points, but I'm just going to look at the y-intercept, okay? The y-intercept of this line is 0, 8. The equation is just going to be y equals 8. That's it. Done. Nothing else to do. But again, this is only for horizontal lines. Now look at this one. Where does it cross the y-axis at? 0, negative 4. In fact, every point on this line, this point, this point, this point, this point, you can do it all day. Every one of those points, the y-coordinate's negative 4. And all you write for that is y equals negative 4. Done. That's the equation. No having to do slope, no having to do rise over run, none of that stuff. All right, let's look at the other two. Now, these are vertical lines, right? Every vertical line's slope is undefined, okay? Now, for that case, we don't use y, we use x. So let's check this first one out here. X equals, all you got to do is look at the x-axis. Where does it cross at? It crosses at negative 8. That's it. x equals -8. That's all you got to do. You don't have to do rise and run. You don't have to do any calculations. There's nothing else to it. And again, every point in this line, like let's pick a different point. This point right here is also -8 over. It's -8 over 5 up. Or this point here, -8 over -6 down. All the points on this line all have an x-coordinate of -8. So for this one, it's a special equation. We just write x equals -8. For this one, same thing. X equals, it's a vertical line. Where does it cross the x-axis at? Because that's the easiest place to spot it. Crosses at 5. So all the equation is x equals 5. So horizontal and vertical lines are a little more confusing, but writing the equations is a lot easier. All right, so that's today's lesson. Finding the equation of a line for regular lines and for horizontal and vertical lines. So try today's homework, show your work, and don't be afraid to draw on the graph and do a neat job, okay?